I promised more and more we shall do. Okay, examples 3 and 4. Here we go. So the first thing I notice about this one, I've got parentheses squared, which is a cue that since I have vertex form or a modified vertex form, that's going to be another square rooting problem. So I'm going to solve by square rooting here. So now this time I want to get this isolated by itself, okay? I am not going to square it out, okay? I'm going to get the square thing by itself, square root both sides. It will be more efficient because there's no guarantee that this could actually factor down the road, all right? So I'm going to get rid of the 15 first, and then I'm going to deal with the 3. Let's see, that gives me 27. Now I'm going to divide out the 3 from both sides, and I'm going to have x plus 4 is equal to 9. Oh, sorry, x plus 4 squared is equal to 9. My apologies. Now I need to go through and I need to solve this. So I'm going to square root the left, square root the right. I'm only going to put the plus or minus on the numerical side. That way I don't need to worry about anything later on down the road. So the numerical side will get the plus or minus. All right, so now we're going to have x plus 4 is equal to, in this case, it works out nice, plus or minus 3. So what I have here is I actually have 2 separate equations. I have x plus 4 equals positive 3, and I have x plus 4 equals negative 3, and I want to solve both of them. So the nice thing is they both just subtract 4 to get their answer. So I get x equals negative 1, and I get x equals negative 7. Now, see how I got nice integer whole number pretty answers? That means I could have solved this by factoring, and that would have worked out just fine. However, I want to have a little sidebar conversation with you guys here. All right, let's pretend if it had been x plus 4 equals plus or minus the square root of 3 instead of just a 3. How do we handle that? Because I can't subtract 4 and just get a single number. So in that case, we would write the answer like so. We would write that it's negative 4 plus or minus the square root of 3. And that would have been our answer, okay? Remember, this is an if it had been. This is not the solution. The final solution is down here, okay? So that's problem number 3. So that's a vertex form square rooting problem. Now let's take a look at problem number 4. So here we go, sliding over. All right. Next up. Now I see factors. Don't these look nice? Factors. My problem? This isn't 0. So I can't just do a factor equal to 0 and a factor equal to 0. And I can only solve by factoring if it says equals 0. So I actually need to FOIL this out, because I need standard form to identify what to do. All right, so I'm going to FOIL that out. I'm going to get x squared plus 4x plus 3x plus 12 is equal to 4 minus 2x. I'm going to move some things around, so I'm going to add the 2x over. I'm also going to subtract over the 4, and we're going to get a sense of what this looks like in standard form. So I've got x squared, let's see, 2, 3, and 4, that is 9. And then 12 minus 4 is 8. All right, now looking at this in my standard form, I see a linear term, and a linear term typically means try factoring first. And there are, in fact, factors of 8 that add up to 9. This one's one of our easier factoring problems. This is going to give me x plus 1 and x plus 8, because 1 plus 8 is the 9 for the 9x in the middle, and 1 times 8 is the 8 for the end. So I do x plus 1 equals 0, and I do x plus 8 equals 0, and you can write that x equals negative 1 and negative 8. And that's your final answer there, which doesn't match the factors I started with, but it does work out pretty, okay? Now, I want to point out, it is okay for you guys to jump from the factored form to a final answer. If you want to do these computations here in your head, you are welcome to do so. All right, 4 down, 2 to go. See you in the next one.